For the first time in the history of volcanology, scientists know exactly when a volcano is about to erupt. Not roughly, not in a range of months or weeks, in a window of days. The USGS Hawaiian Volcano Observatory issued its official forecast this morning. Episode 46 of the ongoing Kilauea eruption will begin sometime between Tuesday, May 5th and Saturday, May 9th. WGCU, that is a 4-day window for a volcanic eruption on a mountain that has been one of the most studied, most monitored, most scientifically significant volcanoes on Earth for over 100 years. And as of right now, beneath the floor of Halemaʻumaʻu crater at the summit of Kilauea, the magma chamber is filling. The ground above it is tilting. 96 small earthquakes were recorded in a single morning. Consistent glow is visible from both vents on the webcams overnight. The volcano is charging, and the scientists watching it can tell you, within 4 days, when it fires. Stay with me. Because the forecast window is not the most important thing about what is happening at Kilauea right now. The most important thing is what the pattern of these 45 episodes, what they are building toward. Because there's a detail buried inside the eruption data that the USGS has documented, but that almost no coverage has contextualized. Each episode in this sequence has its own signature, its own fountain height, its own duration, its own behavior. And when you line up all 45 and look at the trajectory, a question emerges that the scientists are watching very carefully. Is episode 46 going to be bigger than anything that has come before it? The data says possibly, and we are going to show you exactly why. First, you need to understand what you are looking at, because the Kilauea eruption that the USGS is forecasting episode 46 for is not a new eruption. Kilauea has been erupting episodically within the summit caldera since December 23, 2024. Since then, 45 episodes of activity and lava fountaining have been separated by short periods without activity. Each episode has generally lasted for less than 12 hours. The lava fountains are separated by pauses that can last anywhere from less than 24 hours to 21 days. Local 10-45 episodes in roughly 16 months, all of them from the same two vents, a north vent and a south vent, inside Halemaʻumaʻu crater at the summit of Kilauea. Research geophysicist Ingrid Johansson of the Hawaiian Volcano Observatory described this eruption sequence as unprecedented. It's very unique. Other episodic fountaining eruptions at Kilauea have not been this regular, she said from the HVO office in Hilo, where she watches tiltmeter data in real time. Wikipedia, not just active, not just frequent. Unprecedented in regularity for this volcano. For any volcano that humans have monitored at this level of precision. Past eruptions at Kilauea often involved slow-moving lava flows that would last anywhere from days to decades. This eruption has had 45 fountaining episodes, spectacular events featuring 2 volcanic vents from which lava shoots high into the air. After studying the eruption's patterns for more than a year, scientists have mastered how to predict when an episode will take place. Wikipedia mastered. That is the word Spectrum News Hawaii used when describing what the HVO team has achieved. A scientific first, a volcanic clock with a precision no instrument ever achieved before this eruption sequence began. Here is what makes this prediction system work. And here is why understanding it tells you something alarming about what episode 46 might do. In the Hawaiian Volcano Observatory office in Hilo, research geophysicist Ingrid Johansson watches readings from multiple tiltmeters set up at Kilauea's summit. Tiltmeters measure how the ground is changing. The ground bulges as the magma chamber fills or inflates and then tilts down as it empties or deflates. As the lines from the tiltmeter's data seesaw, Johansson uses this information to determine when Kīlauea's subsurface chamber is filling with magma, and to predict when it will shoot lava from the vents. Wikipedia. The basic rule of thumb is that the tilt should be back to about the level it was at right before the last episode. Essentially, once inflationary tilt has recovered all the deflationary tilt that occurred during the previous episode. Wikipedia inflation, deflation, a magma chamber filling and emptying like a lung, and carved into the data of that breathing pattern for 45 consecutive episodes now is a rhythm precise enough to forecast. Since the end of episode 45 on April 23rd, the Uekahuna tiltmeter has recorded 0 microradians of inflationary tilt. During episode 45, the tiltmeter recorded approximately 16 microradians of deflationary tilt as magma erupted. The forecast window for episode 46 is based on the assumption that the chamber must refill to the level it held right before episode 45 began. Daily dispatch 9, 0 microradians recovered, 16, 0 needed. The volcano is more than halfway recharged as of this morning. 96 small earthquakes were recorded at Kilauea's summit on Wednesday morning. primarily within Halemaʻumaʻu crater and south-southwest of the caldera. All were less than magnitude. 2. 0. Seismic tremor continues with regular pulses. Daily dispatch. Regular pulses. The volcano has a heartbeat. The scientists in Hilo are watching it accelerate toward the next episode. Here's the detail that should stop you cold. Episode 43, at the summit of Kilauea, began at 9:17 a.m. on March 10, 2026, and continued for 9 hours. The south vent fountain reached 1,770 feet, 540 meters in high. A new record for this eruption sequence, Wikipedia, 1,770 feet. For reference, the Empire State Building is 1,454 feet tall. The lava fountain that erupted from Kilauea's south vent on March 10th was taller than the Empire State Building by more than 300 feet. Southwesterly winds carried tephra toward visitor overlooks and nearby communities near and far. Most of the fallout accumulated at the Wekahuna Overlook and Kilauea Military Camp. In Hawaii Volcanoes National Park, as well as portions of Highway 11 and the Volcano Golf Course community. Part of Highway 11 was temporarily closed. Wikipedia Tephra Fall was reported as far east as Volcano House within Hawaii Volcanoes National Park. The farthest confirmed observations range from Kalapana in the south to Laupahoehoe in the north, with the latter received around 3:30 p.m. More than 200 Tephra Fall reports were submitted in total from across the Big Island. National Weather Service 200 Tephra Fall reports. From Kalapana to Laupahoehoe, a span of more than 80 miles of Big Island coastline. From a 9-hour eruption that produced a fountain taller than the Empire State Building. Then came episode 44. During episode 44 on April 9, 2026, the eruption plume reached 16,000 feet above sea level, reported by the NOAA Washington Volcanic Ash Advisory Center. Pieces of lightweight reticulite, volcanic glass, up to 12 inches across rained down. Near Kilauea Military Camp in the Volcano Golf Course subdivision, Hawaii Volcanoes National Park closed temporarily. Highway 11 was shut down. Wikipedia, 12-inch chunks of volcanic glass falling on a golf course, and on the road that connects the southern half of the Big Island to Hilo. SO2 emission rates during episode 44 averaged over 200,000 tons per day, comparable to the 2018 Lower East Rift Zone eruption that destroyed 716 homes in Leilani Estates. Wikipedia, 200,000 tons of sulfur dioxide per day from a summit eruption confined within the caldera, producing sulfur emissions comparable to the eruption that devastated an entire neighborhood of the Big Island 8 years ago, while the lava itself stayed inside the crater. Here is what is not making headlines. The episodic eruption at Kilauea is escalating. The Volcano DB timeline of the eruption sequence shows a clear escalation arc. Early episodes produced fountains below 1,000 feet. By episodes 41 through 43, fountains were reaching 1,000 to 1,400 feet. Episode 43 set the current record at 1,170 feet. Episode 44 was smaller, described by USGS scientists as a quieter episode, but still produced a plume to 16,000 feet and 12-inch tephra chunks falling on communities. Wikipedia's smaller fountains are not necessarily less dangerous. Episode 44 had smaller lava fountains than episode 43 and still produced more dangerous tephra impact on the communities northeast of the summit, because the wind direction delivered the debris corridor directly into populated areas instead of into the closed park. The danger from any given episode is not only about how high the fountain goes, it is about where the wind is blowing when it does. The ongoing episodic eruption has complicated USGS's ability to monitor its own instruments. Several summit monitoring stations, including the SDH Tiltmeter, remain offline until scientists can reestablish access across the deep tephra field south of the caldera. The tephra accumulation from repeated episodes has buried Crater Rim Drive, making it no longer drivable. CNN. The eruption is burying the road that scientists use to reach their own monitoring equipment. The tephra field is so deep south of the caldera that a tiltmeter station, one of the instruments they use to predict the next episode, is unreachable. The volcano is outpacing its own monitoring infrastructure. Gas monitoring stations near the vents have also been partially buried or damaged by tephra fall. Measuring volcanic gas emissions during the episodic eruption has been difficult, given that the predominant downwind direction during trade winds has resulted in Crater Rim Drive being buried under tephra. CNN. And there is one more thing the daily updates mention quietly, without elaboration, that has not been picked up by any outlet covering this eruption. Part of the way through episode 44 fountaining on April 9th, earthquakes began occurring just south of Halemaʻumaʻu. Between 4 p.m. and midnight, there were 15 shallow earthquakes of magnitude 2, 0 or smaller extending 1 to 2 kilometers below the south rim of the caldera. Wikipedia. A cluster of 15 earthquakes directly beneath the south rim of the caldera during an active eruption episode, not at the vents, at the rim itself, the structural boundary between the erupting crater and the surrounding rock. The USGS did not elevate the alert level. They did not issue a special notice. They documented it in the scientific record and moved on. But shallow earthquakes beneath a caldera rim during an active eruption episode are precisely the kind of signal that precedes structural instability, the kind of instability that, at other volcanoes, has preceded caldera collapses, rim failures, and the conversion of a contained summit eruption into something far less contained. Now here's the question that episode 46 is building toward. The episodic nature of this eruption, the fill and drain rhythm of the magma chamber, is controlled by a mechanism called a gas piston. The USGS has published a Volcano Watch article specifically explaining it. The magma chamber inflates. Gas pressure builds until it exceeds the resistance of the vent system. The vent opens, lava fountaining begins, the chamber drains, the vent closes, the chamber refills. Each episode is one cycle of that piston. The height of the lava fountain is directly related to how much pressure has built in the chamber before the piston fires. The longer the pause between episodes, the more complete the recharge, the more pressurized the system when it releases. Pauses between episodes can last from less than 24 hours to more than 21 days. Local 10, episode 45, ended on April 23rd. Episode 46 is forecast for May 5th to 9th, a pause of 12 to 16 days. That is one of the longer pauses in the recent sequence. The rapid return of inflationary tilt and strong glow from both Halemaʻumaʻu eruptive vents indicates that another lava fountaining episode is likely. Consistent glow was observed from the south vent on webcams overnight, and intermittently from the north vent. Daily dispatch, both vents glowing, the chamber filling faster than the pause length might suggest. The time between recent episodes has seemingly gotten shorter compared to the prolonged pause between episodes 43 and 44. Wikipedia shorter pauses, more frequent episodes, higher recent fountain heights, a monitoring infrastructure being buried by its own subject, and the East Rift Zone, the system that, when it activated in 2018, produced the eruption that destroyed 716 homes, showing no unusual activity. Now, that last point matters more than it sounds, because the summit episodic eruption is not the worst-case scenario for Kilauea. The worst case is what happened in 2018. The summit system depressurizes, the magma migrates into the East Rift Zone, and instead of lava fountains inside a caldera 4,000 feet above sea level, you get fissures opening in residential neighborhoods at sea level. The USGS notes the absence of East Rift Zone activity in every daily update. They note it because it is what they are watching for. They note it because its absence is reassuring, and they note it because its presence would change everything. Picture this. Somewhere in Volcano Village tonight, a community of roughly 2,400 and 400 people that sits 4 miles northeast of the Halemaʻumaʻu vents on the rim of the caldera, inside Hawaii Volcanoes National Park's outer boundary. A family is doing what they do most nights. They have lived here by choice. In a community that has watched 45 eruption episodes from their front porches since December 2024, that has cleaned tephra off their roofs after episode 41 and episode 43 and episode 44, that has disconnected their rainwater catchment downspouts before eruptions, as the USGS guidance recommends, to keep fluoride from washing into their water supply. These are not people who do not know the risks. They chose this address knowing exactly what it sits on. They have read the USGS daily updates. Some of them have submitted tephra fall reports from their yards through the HVO's online reporting system, contributing citizen science observations that become part of the official hazard record. They are living inside the eruption, voluntarily, and watching the forecast window for episode 46 tick down on the same USGS page that the scientists in Hilo are watching. Glow from both vents was observed on webcams overnight, with the south vent significantly brighter. Local 10. The south vent is the one that reached 1,170 feet in episode 43. The record holder. It is significantly brighter tonight. So ask yourself 3 questions. Research geophysicist Ingrid Johansson of the USGS Hawaiian Volcano Observatory described the ongoing episodic eruption as very unique. Other episodic fountaining eruptions at Kilauea have not been this regular. 45. Consecutive episodes in 16 months with a 4-day forecast window now accurate enough to plan around. If a volcanic system that human beings have never been able to forecast with this precision is now forecastable, what does that precision actually tell us about the regularity and the pressure and the mechanics of what is happening inside the chamber beneath Halemaʻumaʻu? And if the system is regular enough to forecast like a tidal cycle, what does it mean? That episode 43 broke the fountain height record. Episode 44 produced 12-inch volcanic glass falling on a golf course, and episode 46 is building during one of the longer recharge pauses in the recent sequence. Wikipedia crater rim drive is buried under tephra and no longer drivable. Several summit monitoring stations remain offline until scientists can re-establish access across the deep tephra field. Gas monitoring stations near the vents have been partially buried or damaged. The eruption is physically preventing scientists from reaching the instruments designed to monitor it. If the monitoring infrastructure is being degraded by the phenomenon it is supposed to be measuring, and the phenomenon is showing no signs of stopping after 45 episodes, at what point does the degradation of monitoring capacity become a safety concern independent of what the volcano itself is doing? CNN. And if 15 shallow earthquakes occurred beneath the south rim of the Halemaʻumaʻu caldera during episode 44, at depths of 1 to 2 kilometers directly beneath the structural boundary between the erupting crater and the surrounding volcanic edifice, and the USGS noted them in the scientific record and continued monitoring without a special notice, what is the threshold at which the contained, predictable, spectacular summit eruption that tourists are timing their Big Island vacations around becomes the structural event that changes the geometry of what this eruption is? Wikipedia. Right now, as you read this, Kilauea is paused. The forecast window for episode 46, based on tilt data from the Uekahuna Tiltmeter, is Tuesday, May 5th to Saturday, May 9th. The window may be adjusted based on continuing observations. WGCU 9. 0 microradians of inflation recovered since episode 45 ended. 16. 0 needed before the piston fires again. Consistent glow from the south, vent overnight. Intermittent glow from the north. 96 earthquakes in a single morning. Seismic tremor continuing with regular pulses. Daily dispatch. The ground is tilting upward at 4,091 feet above sea level on the summit of the most active volcano in the United States. 45 episodes of lava fountaining since December 23rd, 2024. Fountains that have reached 1,170 feet, taller than the Empire State Building. Tephra that has blanketed 80 miles of Big Island coastline. Sulfur dioxide emissions comparable to the eruption that destroyed 716 homes. A monitoring road buried under volcanic glass. A tiltmeter station unreachable across a field of its own product. And in the HVO office in Hilo, research geophysicist Ingrid Johansson is watching the tilt graph on her computer. She knows what the number means when it returns to the level it was at right before episode 45. She knows within a few days when it will get there. She has watched this chamber fill and drain 45 times. The predictability of the ongoing episodic eruption has allowed Johansson and her colleagues to confidently and accurately forecast the next episode. Wikipedia. She will forecast episode 46 the same way. And somewhere between Tuesday and Saturday, the south vent will glow brighter than the north. The tiltmeter will record the moment the piston tips. The HVO will issue a volcano emergency notice. Hawaii Volcanoes National Park will close the viewing areas. The residents of Volcano Village will disconnect their rainwater downspouts. And for somewhere between 8 hours and 8 days, a column of liquid rock will rise higher than any building constructed by human hands, shooting from the summit of a shield volcano that has been building the island of Hawaii from the ocean floor, one episode at a time, for 300,000 years. Episode 46 is coming. The scientists know exactly when. The question, the one that 15 earthquakes beneath the South Caldera Rim in April are quietly asking, is whether episode 46 is going to be what all 45 before it have been, or something else entirely.